Hello guys, how you doing? This is the fifth session of chapter 12 Fluid Mechanics 1. I hope you are doing well. The subject of this session is manometer. Follow me through the whole video. As I have already told you, the subject of this session is manometer. My name is Amir Raza Talaqat and my email address is amirrazatalagat@gmail.com. It might take several minutes to several days, but I try to take an action as soon as possible to answer you the questions you're looking after. At initial step of this session, I'm gonna introduce you to the three pressure measurement devices, which are called manometers. As I've already told you from the previous session, barometer is one of the manometers. Barometer is itself is a pressure measurement device. As you see here, we have a piezometer, which is having one open end. In here, we have a pressure reference, which is atmospheric pressure. The main point of piezometer is that if we have a point A here, the pressure A is equal to pressure P1 here, since we are having same elevation. The point of a piezometer is that it is only suitable for the pressures greater than atmospheric pressure, unless the atmospheric pressure is going to be sucked in here. This means that if we have a PA less than P atmospheric, the P atmospheric is going to be sucked all over this area and fills this area. The other point is that it is better for us to consider liquid here rather than gas, since it is more dense and it is more suitable to be filled in the piezometer. The second type of manometer is a U-tube manometer. Itself has two categories, one open end and two closed ends. Here's the one open end. In here, if we have, as long as we are having same elevation, P1 is equal to PA here. It is verified already, and it is the fact. The advantage of U-tube meter is that we can have two different fluids at the same time and verify their pressure difference simultaneously. Again, here if we have a heavy fluid, we can already maintain the whole situation. Heavy fluid like mercury. But if we have a light fluid such as water, it is best for us to increase the height of this section in order to maintain the whole situation. So the point is, first, if we have heavy liquid, the whole situation is going to be remain same. And if we have a light liquid here, it is better for us to increase the height here. The pressure of point A is gamma 2 H2 minus gamma 1 H1 due to equation 2.12. There's another point I'm going to mention. The contribution of gas columns in manometers is usually negligible since the weight of the gas is so small. It is telling that as long as the density of the gases is so small regarding amount, we can neglect the distribution of them in the area of the tube. So it is not concernable. Let's take a look at an example in order to verify YouTube manometer better. Follow me with the example. Welcome guys to the solving problem of example 2.4 from chapter 2 section 2.6 simple YouTube manometer. Let me just read the question. A closed tank contains compressed air and oil. SG oil is equal to 0.9 as shown in figure E2.4. A YouTube manometer using mercury SgHg is equal to 13.6 is connected to the tank as shown. The column heights are H1 as 36 inch, H2 6 inch, and H3 9 inch. Determine the pressure reading in PSI of the gauge. So, if we want to have, let me just verify the points of the example once again. We had the SG oil as 0.9, SgHg as 13.6, H1 as 36 inch, H2 as 6 inch, and H3 as 9 inch. So, here we go. If we want to have the pressure of point 1, we can write it as this. P1 is equal to P air, because it's in above of that point, plus gamma oil multiplied by H2 plus 1. So, if we decline this amount here, let me just read it here. P1 minus gamma H3, gamma Hg. H3, we're gonna have 0 because it is also connected at the other side of the air. This means P air plus gamma oil H1 plus H2 minus gamma Hg H3 is equal to 0. The minus sign here, it means that we are going upward. The plus here, gamma oil H1 plus gamma oil H2 is going downward. This whole thing means downward. So, we have it as this. P air plus SG oil multiplied by gamma H2 multiplied by H1 plus H2 minus SgHg gamma H2 H3 is equal to 0. So this means that we have this means P air is equal to minus 9.1. It is headed to that way. The whole of this area is coming here. This means minus 0.1 multiplied by 62.4 pound per cubic feet. Plus 36 plus 6 over 12 in order to convert it to feet, plus 13.6 62.4 multiplied by 9/12. This means P air is equal to 440 pounds per square feet. If we divide it by 144, it is going to be converted to PSI. It's 3.06 PSI gauge. This is the pressure reading gauge of PSI. Welcome back, guys. The second type of YouTube manometer is two closed ends, which we have it here, which is named as differential YouTube manometer. The pressure of point B is equal to pressure of point 5 since they are in the same elevation, and it is the same for P1 equal to PA according to the same interpretation of same level. If we have a pressure A which is equal to pressure of 1, going downward is going to add the pressure. So PA plus gamma 1 H1 minus gamma 2 H2, which we are going upward. This means we are having a decrease in the pressure amount, minus gamma 3 H3 is equal to PB, which is 0.5. PB is equal to P of 0.5. Doing the calculation, we have PA minus PB is equal to gamma 2 H2 plus gamma 3 H3 minus gamma 1 H1. It is very convenient device to have it for measuring pressure difference at different levels. Guys, if you have a YouTube manometer, you have to look after some important points. First, you have to look after the numbers and the homogeneity of your equations. It is the first and most important term of YouTube manometer. Second one is capillarity. As long as we have not considered surface tension and all of YouTube diameters are the same, the capillarity is not considered. The third point is that picking the fluids, water and mercury, since they both have meniscus property. And fourth and the last one is that in order to have an accurate measurement, you have to look after temperature very much, since temperature is really affecting the specific weight. As you see, the equation here is illustrated in this figure either. Gamma 3 H3 plus gamma 2 H2 minus gamma 1 H1 is equal to PA minus PB. So there is another example for YouTube manometer with the two closed ends. Follow me with the whole solving example. So welcome, guys, to the last problem solving of this session, which is example 2.5, chapter 2, section 2.6, YouTube manometer. Let me just read the question. As will be discussed in chapter 3, the volume rate of flow Q through a pipe can be determined by means of a flow nozzle located in the pipe as illustrated in figure E2.5a. The nozzle creates a pressure drop PA minus PB along the pipe, which is related to the flow through. The equation Q is equal to K square root of PA minus PB, where K is a constant depending on the pipe and nozzle size. The pressure is frequently measured with a differential U-tube manometer of the type illustrated. So let's find A. Determine an equation for PA minus PB in terms of the specific weight of the flowing flow gamma 1, the specific weight of the gauge fluid gamma 2, and the various heights indicated. B. For gamma 1 is equal to 9.8 kilonewton per cubic meter. Gamma 2 is equal to 15.6 kilonewton per cubic meter. H1 is 1 meter. H2 is 0.5 meter. And it wants to identify what's the value of the pressure drop PA minus PB. So let's go for the solve procedure. If we want to have PA minus PB, let's illustrate it in this way. We have PA minus gamma 1 H1 minus gamma 2 H2. Guys, when we are at point A, when we go upward, the pressure is going to decrease. And since it's in the same level of section 2, as long as we go up, then the pressure decreases. When we go downward, we have this plus gamma 1 H1 plus H2. Because at this section we have the same material as point 1, we have gamma 1. And we plus H1 to H2 owing to the fact that we are going downward. P increases. So we reach PB. This means doing the calculation, PA minus PB is equal to H2 gamma 2 minus gamma 1. We can replace it as this, 0.5 multiplied by 15.6 minus 9.8, both in kilonewton per cubic meter. This is also meter. We're gonna have 2.9 kilopascals. Guys, in these kinds of questions, pay attention when you go upward, the pressure decreases, as this. At the section 2, you are also going upward, the pressure decreases. At the other side, when you're heading to point B, you're going down, the pressure decreases. Pay attention to these points. Welcome back, guys. There is another specific type of U-tube manometer with two closed ends, which is inclined. It is very used in utilities, industries, and so on. So let me just verify the whole equation, and I'll give you the illustration of the whole concept. If we have a pressure of point A, we have to added to gamma 1 H1 minus gamma 2 L2 sine theta minus gamma 3 H3 and equal it with pressure B. Let me illustrate you the whole equation. When you have L2 in an inclined angle, if you multiply the L2 with the sine of theta, you're gonna have this height. So this height is L2 sine 2. When we go downward, the pressure is gonna be added. When we go upward from here to here, the pressure is gonna be decreased. And when again we go upward, the pressure is going to be decreased. This is the main reason why we have negative signs here and here. Doing the whole calculation, we have equation 2.15. In order to simplify it for gaining the length of L2, we can have equation 2.16. Guys, if we have a limitation of this equation having with theta going to 0, this means this section is going to be 0, which means we have infinite length. This means that if we have an inclination of 0, this means we have infinite length, which is not somehow suggested to do that. And by the way, if we have inclination like this, the fluid might sometimes come down much more smooth. This is the main reason why we are using such YouTube manometer as inclined YouTube manometer. So this is the end of the fifth session of chapter 2 of Fluid Mechanics 1. I hope you have acknowledged all of the subject of this video, and I'm very happy that you have followed me till this moment of the video. And I'll be so much appreciated if you subscribe the whole channel in order to get the notification of all upcoming videos. I bid you all farewell. See you in the next session.